So today we are going to learn about the product and the quotient rules. The product now, before we learned that if you have a sum of functions and if you want to find the derivative, you just take piece by piece and differentiate. Okay, so if you have say x squared plus 3x squared, then you differentiate x squared and then plus you differentiate 3x squared. Okay, but if you have a product like this, now this is one piece and a second piece, you cannot do that. You can't just differentiate this times differentiate that. That's wrong. For example, the derivative of this is not 18x squared minus 1 times 0 minus 3. It is not that. Okay, so there is a separate rule for this type of problem when you have a product, and the rule is pretty simple. The only kind of worrisome part here is the algebra which you have to use when you want to simplify your product. So now here, so let me take the derivative, and when you take the derivative, what you get is we have two pieces here. If I call this piece the first piece and this piece the second piece, the rule is very simple to understand. The derivative is equal to write the first piece. That means without differentiating, just write the first piece, multiply that by the derivative of the second piece, plus write the second piece and then multiply that by the derivative of the first piece. Okay, so once again, write 1 derivative of 2 plus write 2 derivative of 1. So when I say write, you just write it without doing anything. Alright, so here, now let's do this example. The first piece is this, the second piece is this. Okay, so first of all, write the first piece. Alright, so what I should do is just write the first piece. So what I do now is write the first piece. Everybody okay with that? Alright, now what you do is differentiate the second piece. So what's the second piece here? The second piece here is this one right here. So if I want to differentiate this, what do I get? I get the derivative of 12 is 0 minus the derivative of 3x is 3. Okay, so this right here is the derivative of the second piece, the derivative of this. Okay, plus, okay, write 2. Okay, write 2. So what is write 2? Write 2 is this, and so plus write 2, and then derivative of the first piece. So this is the derivative of the first piece. Why is that? The first piece is this. So what will be the derivative? So 6 is an attach, multiple attach. So it's 6 times 3x squared. You can say 6 times 3x squared minus the derivative of x is 1. The derivative of x is 1. Is everybody okay with that? So this is the derivative of second piece, right? Okay. So once again, let me go through it. It's write 1, derivative of 2, which means what? Write 1 is must write this, write 1. Derivative of the second piece, derivative of 2, which is what? Negative 3, 0 minus 3, plus write, so I'm up to here, write 2 derivative of 1. Okay, so what is write 2? So this is write 2, and the derivative of 1 is what? The derivative of this, which is 6 times derivative of x cube is 3x squared minus 1. So 6 times 3x squared then minus 1. So basically the differentiation, the calculus part is done with this step. Now I'm done differentiation, but this is not the final answer. You need to simplify this to get the final answer. Now that's the part that bothers students most, really, because the rule itself is very simple, but there's not much I can do about just somehow the bank into algebra, right, and then do the maximum differentiation. So let's the maximum simplification. So now let's try to simplify this. So 0 minus 3 is negative 3 times 6x cubed minus 6x cubed minus 6 plus 12 minus 3x, 12x minus 3x. Now when you simplify this, 6 times 3x squared is what? 18x squared minus 1. So 18x squared minus 1. So now you would want to distribute this. What do you get? Minus 18x cubed minus 16x cubed minus 3 minus 1 x is plus 3x 12 times 18x squared, which is what, 216x squared, minus 12 times minus 1 is minus 12, minus 3 times 18, right here, minus 3 times 18 is minus 54, plus minus 3x times minus 1 is equal to plus 3x. Alright, so we have now, now what I do is I collect the like terms. So I have an x cube here and I have a negative 54x cube here. That will give you negative 54, negative 18, which is negative 72. Then I have a 216x squared there. There's no other x squared here. 216x squared plus 3x plus 3x, which is 6x, and then minus 12. So that's just algebra. The derivatives, the differentiation step is done with this step, okay? That will carry majority of the credit unless it's a multiple choice question, right? So basically make sure that you get a differentiation correct and then try to do the maximum simplification using algebra. So this is the final answer. Let's take another example. Once again, can you see from outside what do you see? You see a product, right? Can you see the product? So what is the part 1? The part 1 is this. And what is the part 2? Part 2 is this. So let's use the formula. Write 1. So write 1 would be what? This one. I'm writing it as a power. It's much easier. Then what's the one? Derivative of 2. Okay. So derivative of 2. So this is 2. What's the derivative of this? The derivative of this part is 2x squared. So it is like 4x minus the derivative of this is 2x. So 4x minus 2 plus write 2 is this part right here, 2x squared minus 2x plus 4 times the derivative of the first piece. So derivative of this. So what's the derivative of that? That is x to the 1/2. So if you take the derivative, you get 1/2 x to the negative 1/2. So 1/2 x to the negative 1/2 is the derivative of 2. Once again, write 1 derivative of 2 plus write 2. So write 2 and then derivative of 1, which is the derivative of square root x, which is x to the 1/2. So 1/2 goes first, and then after that it's a matter of simplification once again. So if I distribute this out, I have x to the 1/2 times 4x, right? And then you know that when you multiply two powers of x, then you add the suffixes of 1/2 here and a 1 here, that will add up to get 3/2. So and then so x to the 3/2, then x to the 1/2 times negative 2 is negative 2 x to the 1/2. Then you get 1/2 times 2 is equal to 1. X to the 3/2, x2 times x to the negative 1/2. So x to the 3/2. So 2 plus 2. So what you do is you add 2 and negative 1/2, which will give you what, negative 3/2, right? And then you have these two. When you multiply negative 2x times positive 1/2, they will cancel off and you get x times x to the negative 1/2. So once again, when you add the powers, you get 1, and negative 1/2 here is 1/2, and then 4 times 1/2 is 2x to the negative 1/2. So when you add these things together, you get 4x to the 3/2, and there's another x to the 3/2 here. So that's 4 times x to the 3/2, 5. So altogether 4 plus 1 is 5. 5 times x to the 3/2, and then you have x to the 1/2 and x to the 1/2 here, negative 2 and negative 1. So negative 3 times x to the 1/2 plus 2 times x to the negative 1/2. So finally, this is fine, but you write this as a positive answer. So once again, after some algebra, you get the final answer. But the derivative step is done from this. Okay. Now finally we go on to quotient rule. Now the quotient rule is used when you have a quotient. Now can you see, like in this example, you have a quotient, you have something on top and this other thing on top, bottom, and you want to find the derivative. What you do is this. The rule is very simple. Write bottom, differentiate top, and then write top, differentiate bottom, and then you must remember to divide by the bottom squared. So write bottom. What is right bottom? The bottom is this. You just write it, right? Okay. Alright, so it's 2x squared minus 1, and then differentiate top. So how do you differentiate the top? The top is this 2x squared plus 1. So if you differentiate this, you get what? 2 times 2x, which is 4x, plus the derivative of 1 is 0. So it's 4x. So we have 4x here, right? Minus, now you go to the minus part, right? Minus. Right top. So let's write top. So right top would be the right of the top, which is 2x squared plus 1. So 2x squared plus 1. And then differentiate the bottom. So what's the derivative of the bottom? This is the bottom here, 2x squared minus 1. So derivative of that will be 4x, right? And then bottom squared. So which is what? Bottom is what? 2x squared minus 1. So the bottom squared is 2x squared minus 1 squared, right? So now it's a matter of distributing this out. 2x squared times 4x will be what? 2 times 4 will be 8. X squared times x will be x cubed. So 8x cubed minus 4x minus, then inside this you get what? You get this 2x squared times 4x, right? Okay, so 4x, it's to go off. So 2x. So let's see. We had 2x times plus 4x, so you get 8. 2 times 4 is 8. 8x cubed, and then plus 4x. Okay, plus 4x divided by 2x squared minus 1 squared, right? Okay, and then 8x cubed minus 4x. 8x cubed minus 4x, and then you distribute the minus, you get minus 8x cubed. Then when you distribute the minus again, you get minus 4x divided by 2x squared minus 1 squared, because the bottom squared is there. So the bottom is 2x squared minus 1. So that part will always be there. Bottom squared, and bottom squared. So now when you distribute this out, this is what you get. And then what happens is the 8x squared, you can say that will cancel off with the negative 8x squared. So this will be gone. Okay, so this will cancel off, right? I mean, this will cancel off with that. So now what happens is in the end, then you have negative 4x, and negative 4x will be negative 8x, and divided by 2x squared minus 1 squared. So once again, when you have a quotient, so when you, in summary, when you have a product of two things, you use the rule right 1 derivative of 2, right 2 derivative of 1. When you have a quotient like this, you use the rule bottom times derivative of top minus top times derivative of bottom divided by bottom squared. Okay, something happened here. Let's see. Okay, all right, good. All right, we'll see you in class.